Okay, so for problem number 1, we need to find the horizontal asymptotes of this function. And keep in mind that when you're finding the horizontal asymptotes, that's the same thing as taking the limits at infinity and negative infinity and seeing what those results are. Now, when you have a function that has just polynomials, oftentimes the limit at infinity and the limit at negative infinity are going to be the same. Sometimes they're not, but oftentimes they are. But when you have a function like this that includes exponential terms, then the limits at both sides are definitely not going to be the same. So you have to do the limit both at infinity and at negative infinity. So first, let's do the limit as x goes to infinity of this function. And there's a couple ways you can do this, one of which is your typical way that you probably learned in the book where you divide every term by e to the x, and then you just solve from there. You can also see that it kind of works out that this is essentially kind of like a polynomial where the degrees just keep getting larger, but they're always the same. So you can kind of think of it as your polynomial of matching degree and use the coefficients. But let me do the dividing by e to the x method. So what I'm going to do is multiply both the top and bottom by 1 over e to the x. And essentially, I'm dividing the top by e to the x and dividing the bottom by e to the x. So when I do that, your numerator just becomes 2, because the e to the x's would cancel out. And on the denominator, we would get 1 minus 1 over e to the x by distributing this 1 over e to the x times both of those. So now we can take our limit as x goes to infinity. We know that e to the x as x goes to infinity, that just keeps getting larger and larger, so that goes to infinity. And whenever you have a constant term divided by a term that's tending towards infinity, then that term is tending towards 0. So this essentially becomes 0 as you do this limit. So then we get the limit as 2 over 1, or just 2. So that's the limit as positive infinity. We also need to do the limit at negative infinity. As x approaches negative infinity. All right, so in this case, we actually can't do what we did here because as x goes to negative infinity, e to the negative infinity becomes 0. So we're kind of would be dividing by 0 here. Instead, we can just kind of look at what happens to these terms. So remember, e to the negative infinity is the same thing as doing 1 over e to the infinity, which is what we just did here. So each term e to the x as x goes to negative infinity becomes 0. So this becomes the following. This would become 2 times 0 over 0 minus 1 as you're doing that limit x to negative infinity. And in that case, that's actually just a number that we can evaluate because the numerator is 0, the denominator is 0 minus 1, negative 1. 0 divided by anything that's a constant number is 0. So we get 0. So when we took the limit at positive infinity, we got 2. When we took the limit at negative infinity, we got 0. So that means we have 2 horizontal asymptotes, y equals 0 and y equals 2. And that would be your final answer here.
The Teaching Center, UF's Learning Resource Center.